All right, this is lesson 4.3, part 1, over linear function patterns. So we've been learning about functions and what they are, and now we're going to look at a specific type of function called a linear function and what type of pattern that forms. So just as a quick review, if you remember, a function is a relationship between a set of values. So in math, we say that something is a function if it's relating some value, what we call the input or the domain, with another value, the output or the range. And so you see that here with these coordinate points 1, 3, 2, 4, 3, 1, 4, 3, and this is what they look like on the graph. That's forming a function because it's relating those numbers. It's relating 1 and 3 together, 2 and 4, 3 and 1, 4 and 3. And if you also remember, that is specifically called a function because it's only one input for every one output, right? It's one to one. But really what we're trying to make sure we understand is that a function is a relationship between a set of values. This number 1 goes with this number 3. This number 2 goes with this number 4. Remember, and it's the x's down here related to the y's right here. What we're talking about this lesson is a specific type of function called a linear function. That's a relationship between a set of values that specifically forms a line on a graph. So if we have points, like these coordinate points here, that are a function, right? They're a set of related values, and they specifically form a straight line on a graph. Okay, that is called a linear function. You can see the word line inside of linear. So that's a very common type of function. We work with it often in algebra. It's this idea of things forming a line, or what we'll also talk about is things about constantly changing, right? So a linear function has a constant change in the input and the output, right? It doesn't go up really high and then go up really low and then decrease or increase again, right? It's just constantly going up at the same pace or the same rate, or it's constantly going down at the same rate. So you can see here in these input-output tables that as the t here, as that input increases 0 to 1 to 2 to 3, this value down here, my output, is increasing 250 to 333 to 416. It's increasing 83 meters each time, right, in this particular table. So you can see it's constantly changing at the same rate, right? It's increasing by the same number each time. Same thing over here, right? As the input increases by 1 each time, the output is increasing by 3 each time. So if we see in a input-output table, or with whatever function we're looking at, in whatever form it is, if we see that it's increasing or decreasing by the same number each time, that's going to be a linear function. And if we were to graph either of these, we would see it forming a straight line. All right, so when we're talking about linear function, that's all we're talking about. It's a set of values that are related, like what you're seeing here in these tables, where they're increasing or decreasing at the same rate. Okay? They're going to form a straight line. That's a linear function. If it forms a straight line, that's a linear function. So the overall goal for this lesson, this is a two-part lesson, and the overall goal for both of these parts is to write linear functions as graphs, tables, and equations. And so we've looked at graphing a little bit and how to graph points. We've looked at XY tables. And how to take a graph and put it into a table, or take a table and put it into a graph. But we want to also be able to write these functions as equations, like what you're seeing here with this y equals 0.5x minus 4. And we want to be able to go in between the three of these as well. I want to be able to take an equation, write it as the table, and write it as a graph. And I want to be able to take the graph and write it as a table and write it as the equation. All right, so I want to be able to go in between the three of those. Now the thing that I really want you to understand is that those are actually three different ways of representing the same thing. The graph, the table, and the equation are all showing me the same thing, and they're all talking about the same thing, just in a different way. Let me give you an example. Say that you wanted to learn about the states, the 50 U.S. states, or you at least wanted to learn their names or something about their names. Well, you could look at three different things. You could look at a lot of different things, but you could look at three different things to learn about that. You could look at a map of the U.S. states. And that map would show you the states, and it would also show you a little bit of their form, right? Their shape of each of those states and how they're related to each other. Which ones are on the west coast, which ones are on the east coast, what's on the south, what's in the north. You could also just look at a list of the 50 U.S. states. Look at them in alphabetical order. Maybe you're trying to learn how to spell them, or you're trying to learn, just it's easier to count here maybe on this list. And so that's a different way of looking at the states. Or maybe you're wanting to learn about their names and the origins of their state names. So you read this little article about the origins of their names. In all three of those cases, you're learning about the states, right? It's showing you the same thing. It's showing you the states. But it's just showing you in a different way because you're looking at it for different information. Look at it, think about it this way as well. Say you wanted to look at Kansas. I can look at Kansas as just the counties, right? So this is the state of Kansas, and these are all the counties. So I could look at it as just the counties, right? That's one way of looking at Kansas. I could look at it with all of the major roadways and all of the cities. Okay? This is what that map would look like. Or I could look at it with all of the major rivers and lakes and streams that run through Kansas and the counties that they go through. And where they are in relation to each other. So in all three of these, it's showing you the map of Kansas. But it's showing you in a different way, and it's giving you different information. That's the same thing here. This graph, this table, and this equation are all showing me the same thing, but it's giving me different information. The graph is showing me a little bit the form of it, showing me that it's a line. The table is showing me which numbers are related to each other. That's a little easier to see here. And the equation is actually giving me a lot of information, even if it doesn't look at it, because I can plug any number into here and figure out what numbers are related to each other. And I can also, which you'll learn this more in Algebra 1, get an idea of what the graph looks like just from looking at the equation. So they're all giving you this different information about the same thing. And so that's what we're trying to do in this lesson, is to work with graphs, tables, and equations. And in this part of the lesson, we'll be looking at the table and trying to create the equation. Okay, so we'll be looking at the table and trying to create the equation. So let's do an example of that now. All right, so this is example 2 on page 9 in your notes. And it says that to use the table to write a linear function that relates y to x. So we're given this xy table here, and we want to write an equation of this function, and specifically a linear function. So it's going to form a straight line. And we're going to use this table to write that equation and see what it looks like in that form. So to do that, we can actually use the skills that we were learning the last couple days when we were looking at patterns and how do we look at a pattern of numbers and then determine what that rule is. It's a very similar skill. So I'm going to rewrite my table out here: -3, -2, -1, 0, 9, 7, 5, and 3. And what I'm going to try to do is I'm going to try to turn -3 into 9. How do I take the number -3 and what operations can I do to turn it into a 9? And how can I take -2 and turn it into a 7? If you remember from our work with the patterns, hey, how do we, what's changing in the numbers, and how do we relate the number over here, the term number, to over here? Now here, our terms are negative, right? That's different than what we were looking at. But it actually works the same way. How do I turn this -3 into a positive 9? And you might have to play around with it to figure it out. So the first thing I think about is when I have -3 and I want to turn that into 9, I realize that I can do -3 times -3, and that gives me positive 9. All right, so if I just take -3 times -3, that gives me positive 9. So let's see if that works for the others. -2 times -3 is equal to positive 6. But we need it to equal 7. So that's not going to work because I have to do the same thing for all of them, right? I can't just add 1 here to get it to 7 because then I'd have to add 1 over here as well, and that's no longer equal to 9. So because I have to do the same thing to all of them, because that's what it is for the function. The function represents all of these numbers. So I know I'm not going to be able to multiply by -3. But I know that multiplying by a number is going to get me close to the numbers I need to get to. So let's try a different number. Let's try -2. Instead of multiplying by -3, we'll multiply by -2. So -3 times -2 is equal to 6. Well, that's not 9. But can I add a number to get to 9? Yeah, I could then add 3, and that gets me to 9. So I multiplied by -2, and I added 3, and that gets 9. Now I was able to do that because I'm just trying to get to 9, right? And so I want to see, can I do that also for -2? Can I take -2 times -2? That's equal to +4, and then if I add 3 to it, because I have to do the same thing, add 3, that gets me to 7. All right, well that's what I wanted. That's good. Let's see if that works for -1, because if it works for 3 of them, I bet it works for all of them. I'll take -2 times, oops, that was the other way. -1 times -2 is equal to +2, and then +3 is equal to 5. So I took -1 times -2, because that's what I did for all 3 of these. I'd multiplied by -2, and then I added 3, because that's what I did for all of them, and I get to 5, which is what I wanted. So I was just kind of playing around with it, right? I tried -3 first. I took -3 times -3. That got me to 9, but that didn't work for -2 because it didn't give me 7. And so I tried again. I multiplied this time by -2, and that got me to 6. So I added 3 more to get to 9. And so then I tried that for the others as well. I took -2 times -2. I added 3. That got me to 7, which I wanted to get to. Remember, I'm trying to turn this number into this number. And that's what's over here in my table. And it worked for -1 as well, and it works for 0 too, if you want to work that out on your own. And so each time I took my number, this number over here, which we'll call x, and I multiplied it by -2, right? Remember, and I'm calling it x because all of these numbers here are in the x column, right? So each time I took the number -2 times my x value, that's what was going on here, and then I added 3. And that gave me my y values here. So I took my x values, I multiplied by -2, and then I added 3, and that gave me my y values. And so what I have here is an equation, an equation that represents this table, right? So this table, this linear function table as an equation, is this right here. Y equals -2x plus 3. -2x plus 3. So that process that we went through is very similar to what we did with the patterns. I'm looking at these numbers here and trying to, how do I turn these numbers into these numbers over here? What operations do I have to do? Do I have to multiply? Do I have to add? Do I have to subtract? And then I see if it works for all of them, what works for all of them, and then that becomes my equation. But before we were using n, but now we're going to use x and y, because that's what these tables are here. And so we took -2 times our x values, added 3, and that gives us our y values. So this will take a little bit of getting used to. It's a different way of working and thinking sometimes, but we'll keep practicing this a lot to try to get really good at this. But yeah, this is kind of how we're going to approach these problems, is looking at what's the pattern here, how can I notice what's going on, and then how do I turn these numbers into these numbers, and then that will give me my equation.